Are we alone in the universe? For generations, this question has captivated humanity, weaving its way through philosophy, science, and our collective imagination. From the earliest stargazers to the high-tech astronomers of today, we have gazed at the night sky, wondering whether life exists beyond our pale blue dot. Yet, despite our curiosity, the answer has long eluded us. But what if we are now closer than ever to solving this age-old mystery? Recent discoveries suggest we might be on the verge of a profound revelation. To decode this problem, watch until the end. A surprise awaits you. Subscribe to the channel now so you don't miss out on valuable knowledge, and join me on the journey of independent scientists. The search for extraterrestrial life once seemed like science fiction. For centuries, the idea that planets could orbit distant stars, let alone harbor life, was inconceivable. Only a few decades ago, the existence of planets outside our solar system, so-called exoplanets, was unproven. That changed in 1992, when astronomers detected the first exoplanets orbiting a pulsar, shattering our understanding of the cosmos and opening new possibilities. But could any of these worlds truly support life? And if so, what would it take to find them? To unravel this mystery, scientists have turned their focus to the concept of the habitable zone, a region around a star where conditions might be just right for liquid water, a key ingredient for life as we know it, to exist. In our own solar system, there are several intriguing candidates. Mars, with its icy poles and hints of ancient water flows, has long tempted researchers. Jupiter's moon Europa, shrouded in a thick shell of ice, likely hides a vast ocean below its surface. Saturn's moons, Titan and Enceladus, offer their own tantalizing possibilities. Titan has lakes of liquid methane and a nitrogen-rich atmosphere, while Enceladus spews plumes of water vapor into space, containing some of life's fundamental building blocks. Despite extensive study, no definitive evidence of life has yet been found on these nearby worlds. Still, the presence of water, organic molecules, and energy sources on multiple bodies within our solar system raises an exciting prospect. If life could arise in more than one place here, it might be common throughout the universe. But our gaze does not stop at the edge of the solar system. The real revolution in the search for life began with the discovery of exoplanets, worlds orbiting stars beyond our sun. In 1995, astronomers discovered 51 Pegasi b, the first planet found orbiting a sun-like star. Since then, advances in technology and dedicated missions, like NASA's Kepler Space Telescope, have revealed thousands more. Kepler's simple yet powerful approach, staring unblinkingly at 150,000 stars and measuring tiny dips in their brightness as planets pass in front, has transformed our understanding of the galaxy. Among Kepler's most significant discoveries is Kepler 186f, the first Earth-sized planet found in a star's habitable zone. Its size and potential for liquid water make it a compelling target in the search for life. Other planets, like Kepler 62e and Kepler 62f, orbit their own stars within the habitable zone and could be entirely covered by oceans. These Earth-like planets suggest that the conditions that fostered life here are not unique. The numbers are staggering. Thanks to missions like Kepler, scientists estimate there could be billions of planets in our galaxy alone that are similar in size and temperature to Earth, potential homes for life. And with billions of galaxies in the observable universe, the odds of life beyond Earth seem to increase exponentially. Yet, a critical challenge remains. Even if a planet lies in the habitable zone, with water and the right chemistry, life may not necessarily emerge. The origin of life is a complex process, one that we barely understand even on our own planet. But if we discovered evidence of life twice in our own solar system, say on Earth and on Europa or Mars, it would suggest that life is not a cosmic fluke, but a natural outcome of the universe's laws. So, how do we proceed? The solution lies in a combination of exploration and analysis. Robotic missions are being planned and launched to probe the surfaces and subsurfaces of Mars, Europa, and Enceladus. These missions will search for biosignatures, chemical signs of life, whether past or present. Meanwhile, powerful telescopes, both on Earth and in space, are scanning distant exoplanets for telltale signs in their atmospheres, oxygen, methane, or other compounds that could indicate biological activity. The search is not without its setbacks and surprises. Some early exoplanet discoveries, such as those around pulsars, revealed planets in environments likely too hostile for life, bathed in deadly radiation from dying stars. Others, like 51 Pegasi b, are gas giants orbiting so close to their stars that they are inhospitable. However, with each new discovery, our methods improve, and our catalog of potentially habitable worlds grows. The next breakthroughs may come from missions like the James Webb Space Telescope, designed to peer deeper into space and analyze the light from distant worlds with unprecedented precision. As technology advances, we may soon be able to detect the chemical fingerprints of life, if it exists, on planets orbiting stars many light-years away. In the end, the question of whether we are alone remains open, but never before have we been so close to an answer. The universe is vast, filled with billions of stars and even more planets. The ingredients for life appear to be common, and the processes that gave rise to life on Earth may be universal. If life could arise here, and perhaps elsewhere in our solar system, then it could be thriving across the cosmos, waiting for us to discover it. If you've watched this far, congratulations! You are truly a passionate scientific explorer, always persisting and conquering every challenge. Let's subscribe to the channel so we can keep on discovering together. Perhaps soon, we will make the discovery that changes everything. A signal in the ice of Europa, an undeniable biosignature in a distant planet's atmosphere, or even something entirely unexpected. Until then, the search continues, fueled by curiosity, innovation, and the enduring human desire to find our place in the universe. The answer to the greatest mystery of all may be just around the corner.